Hi guys, in this video we're going to look at Ohm's law. We're going to talk about the properties involved in Ohm's law, Mr. Ohm who came up with the law, then we're going to look at the law and look at a couple of examples of how we can calculate resistance using this law. So firstly, the things that we're looking at are current, being the flow of electrons around a circuit measured in amps, voltage being the electrical pressure pushing those electrons around the circuit measured in volts, and the resistance being how hard it is for the electrons to get through a particular component, and this is measured in ohms. Alright, so this is the guy who came up with the law, George Simon Ohm, and he was around in the 18th century as a Bavarian physicist. So Bavaria is now Germany, but this was before Germany was united über alles. So he's the one that came up with the law, and therefore the unit of resistance that he proposed is named after him. It has the symbol omega, which is the Greek letter for O, and we call it the ohm. So the law as he wrote it was the potential difference across an ideal conductor is proportional to the current through it, with the constant of proportionality being called the resistance, which is, it's words. Once we actually put it into numbers, it'll seem much easier than that. But basically all it's saying is that the voltage or potential difference and current are proportional to each other by a constant. We call this constant the resistance. So putting it into numbers, it becomes very easy. V being voltage equals I being current, and R times R being resistance. Now remember, current is measured in amps, which have the symbol of A, but the symbol in physics that we use is I, just to be confusing. Well, not just to be confusing. C was taken, so they used I instead. And resistance has the symbol for R, but then the symbol of the units is the omega for ohms, so try not to get confused with those little ones there. We can also put this law into a neat little triangle, and the point of putting it into the triangle is it's an easy way to rearrange the equation into the form that we need it. So all you do to use this triangle is cover up the thing that you don't know or the thing that you're looking for. So for example, if we pretend that this V isn't here, it's V equals I times R because they're next to each other. If we want to find the resistance, we cover up resistance and it's V divided by I. If we want to find the current, we cover up I and it's V divided by R. So it's a nice, and there's a few laws that work like this, and it's a nice, neat way to rearrange that without actually having to think about maths, as long as you put them in the right spot. Alright, well now let's have a couple of examples of how we can use Ohm's law to calculate resistance. So in the first one, I've called it calculating resistance. In the first one we're given the resistance. So we're given the resistance being 6 ohms, and we're given the current being 2 amps. So the thing that we're looking for here is actually voltage. So what we do is we come over to our little triangle, cover up voltage, gives us V equals IR, which is the base form of the equation. So we then plug in I being 2, R being 6. So we've got 2 times 6 gives us 12, and don't forget to put our units on the end. So the voltage is 12 volts. Okay, so that one's pretty easy. Let's have a look at another one. Alright, in this example we actually are going to calculate the resistance, which is probably what you're going to do, because resistance is something that we've talked about before, cannot be measured. You can't get a meter like an ammeter or a voltmeter to measure resistance. It has to be calculated. So here we're given the current being 2 amps and the voltage being 10 volts. So we want to find resistance, so we cover up R, giving us the formula V divided by I. So we put our voltage of 10 and our current of 2 into that, which gives us a resistance of 5, and then units of ohms. So we have a resistance of 5 ohms in that globe. Alright, in this video we've looked at the properties here, voltage, resistance and current. We've talked about George Simon Ohm being the guy that came up with Ohm's law. We've talked about Ohm's law in words, which is that the voltage or potential difference is proportional to the current, and that the rate of proportionality, or the constant of, well, I suppose it's not a constant, but the number of proportionality being the resistance. And we've looked at a couple of examples of how to calculate resistance using the formula V equals IR in the triangle for ease of rearrangement. Thanks for watching, guys. Peace out.